Hi guys, welcome to your video lecture on human population growth, or population growth just in general. Remember, population growth is how much a population is growing, declining, or staying the same. Most of the time it does grow, but occasionally, depending on environmental factors, we see a decrease or just a leveling out of the population. So what do you think? Do you think the human population is growing, shrinking, or staying the same each year? Hopefully, with just a general idea of how human growth works and human development, as well as just studying the world's population over the years, you were able to tell me that it is indeed increasing. But I just wanted to show you how quickly it actually is. How quickly it actually is growing. So if you look at the blue line right here, this is the world's population, or an estimation of how many people live in the world by 1 billion. Here is increasing on the y-axis, or the up and down. On the x-axis, or the vertical, we see the year. So from the year 1050 to about 1550, we barely reach 1 billion. We're not even quite at a billion yet. So we're just in the millions of population here. Now, what you notice, you're starting at 1650 and 1750, we start to see the population grow and rise. And then if you look at 1850 compared to 2017, we see a huge increase, and it starts to look like an upward slope. That is how exponential growth works. It's logarithmic, and we won't get too in-depth into what's going on here as far as the math behind it, but maybe Mr. Ransom will talk to you about it someday. But we see that the population is increasing by powers of 10 is what log growth means. And we have quickly reached, if you can see, from 1950, the world population was about 2 billion, to 2017, the population is almost at a little over 7 billion, and we know we're working our way to 8 billion right now. So the population is really, really increasing, and at a very quick rate. So with the human impacts that we studied yesterday, we're wondering, okay, what is this super increasing population growth going to do with the environment, and how is it going to impact the world, the Earth? So we've got a couple of questions. What are our survival needs as organisms, not even just humans? We know that we need food, water, shelter, and clothing. We need a couple other things as well, especially as humans and as an advanced society. But, oh, and air. But the very basics of our survival, we need food, water, shelter, air, and clothing. But this doesn't mean clothing as in modest. This means clothing as in protection. Like if you were going out in the desert, or even think the summer here, you don't want to go barefoot here in the summer because the concrete or pavement, or even just the sand, is super duper 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 hot. So you want to have something on your feet to protect them. So when we're talking about clothing, we're not talking about covering up and being modest. We're talking about covering up and protecting yourself from the environment. What do we do, or what do we use to meet our survival needs? We use natural resources. Now, do you remember what a natural resource is? We studied those already when we looked at the lithosphere. Natural resources are just, they're things that we use. So they could be like oil or gasoline. Generally, that's what we think of when we think of natural resources. But it could just be like the cotton that we use for our t-shirts, or the leather that I use for my handbag, or the elements that compose my computer that I'm recording on right now. List some natural resources that you know. So I just talked about a few, but there are many, many, many. We can use the potential energy from water as it falls down from a dam. We can use the sunlight, and we can use that as energy. We can use all kinds of things. We use oh, this is weird, but grape skins have been used to make vegan leather shoes, I've learned, and that's pretty funky. So we can use a lot of things to do a lot of resources to do a lot of different things and meet our needs in weird ways. Like if I have grape skin shoes, that's meeting the need of having clothing or something to protect my feet. So what happens as the human population increases? Number 3. As our human population increases, we'll see that the demands for natural resources increase. So we talked a little bit about this yesterday when we talked about the human impacts to the biosphere. But the more humans that I have on the earth, the more cropland I'm going to need because I need to feed these humans. The more factories I'm going to need because I need to clothe these humans. The more fresh water supplies I'm going to need because I need to keep these humans, water is the wrong word, hydrated. There it is. We need to keep these humans hydrated. So we're going to have an increased demand for natural resources. They're going to increase. What is population growth? Population growth is an increase in the number of people that reside in a country, state, county, or city, a defined area. Population growth today, we're talking about it just in human terms, but population growth we can track with any kind of living thing, so plants, animals, or even our microscopic organisms and critters. Generally, we talked about the population is going to increase unless there's something wrong. So sometimes we could have maybe a predator come in and wipe out a big part of the population, then it would decrease. We could have a disease or pest come in that would decrease some of our population. But for the most part, populations are going to increase unless there's an issue. We know, just when we talk about population growth, so we don't see a lot of the issues that we find with population growth here in Bladen County because we're pretty rural, but there are issues as our populations grow. If you think about cities, places to live are becoming harder and harder to find because our population is growing. Again, we don't see that as much in a rural community like where we live because there's always room to build more houses and stuff to develop land, but that's not as true in the cities. And then population growth can vary between state and city or area, just depending on what's going on there. For example, if you think about like wartime, okay, so what do you call old people boomers, right? The boomers are the name for one of the generations that was born after World War II, like grandparents' generation. That generation is called the boomers because we had a boom in babies because people came back from the war and they got married and they settled down and they had children really, really fast. That's why we called it boomers. So we had a big population of young people born in that time period after World War II. So that was a population growth. Before that, though, while the men were off in the war and some women as well, we didn't see a lot of population growth because the men weren't around the women to reproduce. It just didn't happen. So our population growth is going to vary depending on circumstances within the country or the state or just given area. Again, generally it increases. What shape is the exponential growth curve? So when we talk about population growth, we chart it or graph it in what we call a J curve or an exponential growth. It's this curve up like what we saw at on the very first slide. As time goes on, we see the population size increase exponentially, logarithmically, generally by a basis of 10, but you don't need to know that per se. For the purpose of this course, you do need to know that it's not a straight line. So it's not a straight line going up. I know you can see my mouse, so it's not just a straight slope line here. It actually curves up. And the more you study population growth, you're going to know that it's going to reach a limit where it can't go any higher. That's what we call carrying capacity. We'll learn about that in a second. So do you think the human population growth is growing, shrinking, or staying the same? It's growing. We know that, and this graph right here actually shows the one we looked at, the J curve, pretty clearly right here. We've got the curve up. Now the question is, how far up will we go? Why can't most populations grow on Earth forever? So this isn't going to just keep going. Eventually it's going to reach what we call the carrying capacity because we have limited resources. So there are only a certain number of areas that we can make cropland. There's a finite or a definite amount of water on the Earth. So we only have so much water, drinkable water. What are we going to do as the population keeps increasing? There's going to be less available water per person if we divided it evenly. We know, though, we don't divide resources evenly. Generally, resources are divided based on wealth. So basically the rich people get more of the resources, and unfortunately that's very true. So as our population grows, the people who have more money are generally going to have more of these resources, making it harder and harder for those who have less money to acquire the resources they need to survive. If you think about areas with like our third world countries that don't have access to clean, I mean, this is happening right now. A lot of our third world countries do not have access to clean drinking water, and that causes a lot of disease, if you can imagine, within the population, because just simply their water isn't clean. They're sick. They have a limited amount of clean water. This isn't something we generally struggle with here in the U.S., but experts and people who study population growth and just the human health overall are wondering how are we going to prepare if this were to happen, if we were to start having issues having access to clean drinking water. And I mean, if you think just in general, there's a limited amount of food that we can have. That's why biotechnology, you learned about it with Ms. Campbell last year, is so important, because we're thinking of innovative and new ways to acquire or grow resources. What is carrying capacity? I've said this word and thrown it around quite a few times already in the lecture, but a carrying capacity, it's symbolized by a K, not a C, which is funky, but it's the number of people or other living organisms or crops that a region can support without environmental degradation. So basically the carrying capacity is the max number. So we've maxed out, we cannot get any more. What we know is that populations will reach a carrying capacity with their exponential growth where they can't go any further. The limiting resources are going to determine the carrying capacity for group of living organisms. So how much food is there? How much water is there? How much land is there? How much area is there? Limiting resources, again, are environmental conditions that limit the growth of an organism or population in an ecosystem. So they are things that stop the growth. Again, how much food is there? How much water is there? And I only have so much food, so there's only so many organisms that my population can support. One of the big questions that we have here with looking at human population is how large can the human population grow and the Earth still be able to sustain it? You will learn when we study our ecological footprint that if everybody in the world lived like the United States lives, we would need like I think like 6 worlds or something to support the United States. So what we're saying is that we use more resources than we should. If we split it up evenly, the United States, just as in general, as a group of people, they live abundantly. We have other countries and cultures that don't live as abundantly and therefore aren't leaving such an impact on the Earth. Not only that, but we think about a lot of the human impacts that we studied yesterday. They're only going to get worse the more people that we have on Earth. So how do we combat that problem, or how do we prepare for the population that we know is growing? How do we make sure there's enough food without destroying the soil? How do we make sure there's enough drinking water without using all our aquifers? There's a big part of science, environmental science, that's devoted to trying to find these answers, and it actually crosses culture with a lot of other disciplines like chemistry and physics. And even if you go into some of the more like historical, what can we pull from history that's going to help us survive this? So it's definitely a growing field, something you ought to look into if this stuff interests you. Your exit ticket, some things that you should be able to answer based on this lecture. Describe the growth of the human population, what's it doing? And then give 2 examples of things that limit human population growth. Okay guys, have a fantastic day. I hope you enjoyed this video lecture, and I really sincerely hope that you're listening to this lecture instead of just getting the answers. It's not going to help you at all just to scroll through and find my written answers here. You'll get the credit for the notes, yes, but will you really be learning? No. So it's very important that you're actually listening to the videos. Okay guys, have a great day.